Hi, everyone. Welcome to the ninth and final lesson for Off-Chain Code Beginner Web3, where we're going through today what are objects within JavaScript. This is the final lesson for beginner because at this point, once we completed this lesson, you'll have gone through the basics of everything necessary for JavaScript development, and we'll start actually getting deeper into how Web3 interacts with JavaScript and Solidity. So if you've not taken a look at Off-Chain before, highly encourage you to go out to our website, offchain.social, where you can connect to the various different social groups that we have on WeChat, Telegram, WhatsApp, etc. Myself, I've been living in Guangzhou for the past 3.5 years, although recently moved to Shanghai. I work as a software developer for a large financial institution, but I've been very interested in cryptocurrency since 2013 and love traveling around, meeting new people, and talking a lot about cryptocurrency. Feel free to connect with me on any of the social media links that I have below. Again, this is not going to get you to much of an expert level in programming, but it will give you the foundations as a beginner programmer, and it will get you interested in the basics of how any blockchain application interacts with a with the Web3. So we will be taking this as a foundation, and then in the next set of classes, I hope to go deeper and deeper. Today, we're covering objects, and we're really now going to take all the things we've learned in JavaScript and literally wrap it all up into what is an object. An object is able to then describe anything we want abstractly within a programming language. So if we think about what is an apple, we can think of attributes that an apple would have, such as an apple has a color and it could be red, although other apples could be of the color green. In fact, you could say an apple could be of any color. We don't yet know of all the possible colors that an apple could be, but commonly there might be red and green ones. Apples could also belong to another attribute of what species is it. It could be a Fuji apple, it could be a Golden Delicious, it could have many different types of species. We could also say that an apple has attributes of what pests commonly like to eat it. For example, a worm could be something that likes to eat apples, and it is considered a pest. And then it gets into this bigger question of, well, what is a worm? If we look at the worm object, we could say worm objects have favorite foods, of which one of them could be apples, but worms might like to eat other things, like maybe worms like to eat other types of fruit. Worms could also have different types of names, like wormy, or maybe there's some more scientific name for what a worm is called, but you get the idea. Anything you can think of can be thought of as an object, and those objects can have attributes. And in fact, some objects might even have methods. So a baby has attributes of maybe a name and weight, but it might even have methods, like a baby can eat, and the baby could eat, mashed up apples. These are methods where it's actually going to take something as a function and then go do something else. So we use this concept of object-oriented programming as a way of encapsulating what we want to describe. It used to be that a lot of programs didn't really have objects. They would just have a bunch of scripting abilities, and it became very difficult, unwieldy to make these type of software development because we couldn't really describe objects. A lot of programming today is around object-oriented design. And we're going to start taking a look at how that works today in the lesson. So let's go into Code Academy. And again, this is the introduction to objects. We've just gone through some basic functionality. Let's jump on into one of these, creating an object literal. Objects can be assigned to variables, just like any JavaScript type. We use curly braces like this to designate an object literal. So we could say, let a spaceship equal this. Now, in this case, the object is completely blank, but we're basically saying it's going to be filled in here. Whatever a spaceship is, it's going to get defined here. We will fill an object with unordered data. This is data that's organized into key and value pairs. A key is like a variable name that points to a location in memory that holds a value. You can think of a variable as a key and a value. A variable name is the key. Like if I said, my name is Ben, The key is the word name. The value is Ben. A key's value can be any data type in the language, including functions or other objects. But commonly we can think of it like, name equals Ben, age equals 37, et cetera, et cetera, et cetera. We can make a key value pair by writing the key's name or identifier, followed by a colon, and then the value. We separate each key value pair in an object literal with a comma. Keys are strings, but when we have a key that does not have any special characters in it, JavaScript allows us to omit the quotation marks. Let's try it. So let spaceship equal this. If we wanted to, we could do let spaceship equal that was the original starting point, and they're now giving it some attributes. We could say the fuel type of our spaceship is diesel. Not going to go too far, but whatever. Color. Notice how I didn't have to use any quotation marks. Colon is silver. At the end, you don't have to include a comma, and then you put a curly braces and semicolon. Again, spaceship is the object. The keys were fuel type and color, and the values are what come after this colon, diesel and silver. The spaceship object has two properties, fuel type and color. And we put fuel type around it. We needed quotes. Why? Well, you don't technically have to use quotes like in color. We could have put color in quotes, but you have to put quotes when your key has a space in it. Okay, so if you're going to put a space in your key, you're absolutely going to need to use quotes. All right, the spaceship we have so far looks great, but unfortunately it's not going to go very fast at hyperspace travel due to having an inferior fuel source. Diesel fuel is not really what you would probably want to put in your spaceship. Make a new spaceship object named faster ship with the same color as the spaceship, but with a fuel type that equals to turbo fuel. Sure. All right, we need a new spaceship. So we're going to create a new one. We want to call it faster ship equal fuel. They want us to call this turbo, if I could spell it, turbo fuel. And again, we wanted to call this color silver, the same as before. Run. Great, we now have two spaceships, the original spaceship, but then we also have the faster spaceship, faster ship. All right, let's continue on. Now, once you have an object, you can then access properties in it. There are two ways we can access an object's property. The first one is with the dot notation. We've been using the dot notation throughout all these exercises, so it's going to look very, very, very similar. So in here, if I wanted to access the spaceship's color, all I would have to do, is spaceship dot color, and that would return silver. And if I did spaceship dot quotes fuel type, I could access the turbo fuel. Okay. If you try to access something that doesn't exist, you're going to get an undefined return. So let's try this. What is a spaceship's favorite ice cream? Oops, not the spaceship dot favorite ice cream. What does it do? In this case, it's not going to do anything and it's not matching the condition. If we try to console log it out, you'll see the undefined. Let's use the dot operator to access the value of the number of crew. We can see number of crew exists here. Create a variable called crew count and assign the spaceship's number crew property to it. So we'll create let crew count equal spaceship, our object. Then we need to use the dot operator, and we want to access the number crew, which we see here, attribute, and set it equal here. And since that'll print out nothing, let's just go ahead and add in that we want to now print out crew count and crew count. That allowed us to see that we successfully set it equal to 5, and then we printed out crew count equals the crew count of 5. Cool. Again, using the dot operator, create a variable planet array and assign the spaceship's flight path property to it. We can see our flight path is Venus, then Mars, then Saturn. Same idea. Let planet array equal spaceship dot flight path. Run. Again, it's not going to print anything out, but we've successfully completed the exercise because we've been able to set that variable. Pretty simple. What's cool about this is it's very easy to create objects. You can literally put whatever you want in here. And as long as you just keep appending commas on, you can put anything you want. So if we wanted to give the spaceship a name, just create a name. Super awesome ship. Third. And now it has a name. And if you want, you can console log that out of spaceship.name. Cool. Again, go crazy with this. This is something that is very commonly used within programming. And by being able to put attributes on an object, it's going to make things a lot easier to keep track of. Of course, you could have just said spaceship underscore name equals super awesome ship 3. And this is all technically correct. The problem with this is we don't know that this variable is now going, well, if I declared it, we didn't know that this variable was associated with all this other attributes. By encapsulating it together in an object, it makes things very easy to then be able to pass our spaceship to other methods to then say, oh, I need to know the name. I don't need to now pass this variable separately. It all comes together as the spaceship object. Okay. Let's go to the next exercise. Bracket notation. The second way to access a key's value is by using a bracket notation. So see this bracket? We've been doing this before when we were doing all the accessing of arrays. So to use bracket notation to access an object's property, we pass in the property name key as a string. So if you wanted to access, for example, the number of crew from spaceship, you could do spaceship.numCrew as we just did in the last one, or you could do spaceship and then a bracket and then the tick mark numCrew and tick mark and bracket. That is another equally valuable way of accessing it. So let's try it. Let's use bracket notation to access the value of active mission. Here is active mission. From the spaceship object in the codes editor, create a variable is active. So let is active equal and assign it to spaceship object active mission property. Great. And so we can see what's happening. Let's console log it out. Console log is active equals plus is active. Great. We can see that we were able to access it. Using bracket notation and the property name variable provided, console log the property of the active mission property. Well, we already did that actually. Run it again. Done. Pretty easy, right? Next. Property assignment. Once we've defined an object, we're not stuck with all the properties we wrote. Objects are mutable. meaning that we can update them after we created them. So in some cases, objects can be mutable. And in fact, we'll find later, sometimes we don't want them to be changeable. But in this case, the way we've defined it, everything can be changed into anything else. So what this means is, if I wanted to, I could take my spaceship, and even though the color is silver, what if spaceship color, what if I wanted to change it to red? What will it do? If I now console.log spaceship color, is it still silver or is it now red? Let's find out. It's red. What this means is that when you actually change one of these properties inside here, it permanently saves it because it's mutable. Mutable meaning you can change what's inside there. In this case, they wanted us to do gold. We could have done that too. If you try to change something that doesn't exist though, what if we wanted to say the spaceship's age? A new property gets added. Watch what happens. So even though we didn't have an age up here, now we do. So you can actually append on additional information about your object as you wish. You can even delete properties too. So if you wanted to, we could delete the spaceship color. And if we try to then access color, you'll get an undefined. It literally has gone away. Do remember, this is completely different than if you had just set the color to nothing. Undefined is not necessarily the same as this. You'll see that's a different type of response. If I put in something that makes it a little easier to see this. Color equals blank is not the same as this. Okay. You can do both. You could set it to nothing, or you could set it to literally be deleted. Reassign the color property of the spaceship to have a value of glorious gold. Okay. Take the spaceship color, set it equal to glorious gold, but we have to put that in quotes because anytime you have a value, it must be a string value, you're going to have to put it in quotes. Glorious gold. Great. Without changing lines 1 through 6, add a number of engines property with a numeric value between 1 and 10 to the spaceship object. Let's change the age to number of engines, and 10 engines sounds pretty good. Go. Great. Use the delete operator to remove the secret mission property from the spaceship object. So delete spaceship. And we need to delete the secret mission. Now be careful, it is case sensitive. If you were to accidentally type in lowercase m, it would look almost correct. And you would be wrong. Make sure that you have it exactly the same case. Capital M. Great. Next lesson. Methods. Remember that we were talking about attributes before of a baby, like the baby's age and perhaps what it likes to eat. Well, a method would be something like, what if you wanted the baby to eat something? The method would be then calling that function to go eat. So let's try this. When a data stored on an object is a function, we call that a method. A property is what an object has, while a method is what an object does, like a baby eats. Do object methods seem familiar? Yeah, they do, because that's what we've been doing the whole time. For example, console is a global JavaScript object. Remember console.log? We've been doing this the whole time. Console.log is just a method of the console object. Math is also a global JavaScript object, and floor is also a method on it. So when we did math.floor, that was again using the math object and calling a method floor. You'll find that even JavaScript itself as a language is very object-oriented. In fact, most modern programming languages that you're going to come across, Java, even Solidity, they're very object-oriented, and they're going to have functions that are methods, and they're going to have lots of attributes within those objects. We can include methods in our object literals by creating ordinary comma-separated key value pairs. The key serves as our method name, while the value is an anonymous function expression. Let's try it. Let's go down to the example. Below the retreat message in the code, create an alien spaceship object. All right, so how do we create an object again? We'll call it const alien ship. Give it curly brackets. We now have an object. So we now have an alien ship object. It should contain a method .retreat, which will console.log the retreat message. Okay, let's try it. So we need a retreat object. So in order to do that, we could have retreat, which is now going to be defined. That's the name. Remember, this is our key. And we need now it to be a function. So we'll give it a function. And it needs to then do something. So we'll use curly braces again, just like any function declaration. Inside here, we're supposed to console.log, and it wants us to console.log out the retreat message. Let's try. Can we just take retreat message and execute? Great. This will now call this hard-coded retreat message up here. Add another method to your object literal. This method .takeoff should console.log the string spim borp glix blastoff. All right. So we need another one. So again, we'll use a comma because we're now on to the next method. We need to do a takeoff. So take off. And it needs to be, again, another function because it's going to be an action that we want it to do. Function, curly braces, console.log, and pass in the string that we wish to have it spit out. This. Run. Now let's try running these. So down below our object, let's try doing alien ship retreat, and then alien ship takeoff. We no longer wish to conquer your planet. It is full of dogs, which we do not care for. Spim, borp, glix, blast off. You can see that now we're able to use these functions very easily. In fact, if we wanted to, you can call it multiple times. This makes it very easy to repeat code that you need to repeat over and over and over again. And if you wanted to, you could have optionally passed in other things like variables on into these functions, which you could then use to spit out different things. So if you wanted your retreat message to be different, you could pass in a variable, which will then read it from here. Watch what happens. This is different than the original one. We're now able to then pass in exactly what we want, and it's not hard-coded. It's not reading it from global space. We're now passing in exactly what we want. Technically still the same, but still very different. Let's go on. Nested objects. Yes, you could have objects inside of objects, inside of objects, inside of objects, inside of lots of objects. And this is modern programming is just like this. When you get into a large program, you're going to find that your object is going to be many, 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 many objects put together, just like real life. You might say your house has many objects inside of your house. things like, okay, my house has a sofa in it. Well, the sofa has cushions, and the cushions have maybe a pillow inside of it. And the pillow may have many other things that, well, you get the idea. There are lots and lots of objects of SIDA objects. So in our spaceship object, we want a crew object. This will contain all the crew members who do important work on the craft. Each of these crew members are objects themselves. They have properties like a name, a degree, and they each have unique methods based on their roles. We can also nest other objects in the spaceship, such as a telescope, or nest details about the spaceship's computers inside a parent nanoelectronics object. What does this all mean? Well, it turns out to be a lot of code. Let the spaceship equal this. It has passengers, a telescope, some crew, which includes multiple people, of which one is a captain. It has an engine. Then we have this nanoelectronics group of a computer and a backup. Sure. Okay. We can chain operators to access nested properties. We'll have to pay attention to which operator makes sense to use in each layer. It can be helpful to pretend that you're the computer and evaluate each expression from left to right, so the expression starts to feel a little bit more manageable. We took our spaceship here, then we go to the nanoelectronics here, and then within the nanoelectronics, we went to the backup, and then from there we went and accessed the battery. That's what's happening when this code runs. All right, create a variable cap fave and assign the captain's favorite food, the element on the 0th index of her favorite food array, to it. Make sure to use the bracket and dot notation to get the value of the food through nested access. Don't just copy the value into the variable. All right, what does that mean? Well, we need to create a variable, captain's favorite, assign it the captain's favorite food. Well, how do we access the captain? Can we go directly here? No. We have to start with the captain is inside of the spaceship. So we take the spaceship object. Now I want to access the captain. Can I go to the captain yet? No. I have to go to find the spaceship's crew. So spaceship.crew. Now can I get to the captain? Yes. So go to captain. Okay, I want to get to the favorite foods, but they're down here. All right, so let's take the captain's favorite foods. We can use this bracket notation. We have to because it has a space. And we want to access the first one. All right, well, this is an array. How do you access the first element in an array? We go to the 0 index. It's the first one. That's it. All right, we got the captain's favorite food. Right now, the passengers property has a value of null. Passengers, null. Instead, assign it its value as an array of objects. This objects should represent the spaceship's internal passengers as internal objects. Make at least one passenger object in the array that has at least one key value pair in it. Okay, let's first make a passenger. So passenger. What else do we need to do to create this object? We have to give it a bracket. Let's give a key value pair for Ben to say the name of Ben is Ben. Sure, we've done the minimum. Now we want to add this passenger Ben object to the spaceship. How? Take the spaceship and let's access the passengers. Now currently it's set to what? It's set to null, has nothing. What do we want to do? We want to turn that into an array. See, objects in an array, and that has at least one key value pair in it. Well, that turns it into an array, but how do we get passenger Ben in there? can we just passenger Ben inside the array? There we go. I am now the only passenger on this the ship. If I wanted to, let's create a passenger Lara. Now we have two passengers that exist, but only one is on the ship. To get Lara on the ship, I would then have to put in another passenger. Now there are two passenger. Well, now I'm wrong, but you get the idea. That's the correct way of doing it. Let's go back to just the one passenger. All right, create a variable first passenger and assign it the first passenger as its value, the element in the 0th index of the spaceship passenger array that you just made. Make sure to use the bracket and dot notation to get the passenger's object through nested access. Don't just copy it. All right, so let's get the first passenger, spaceship dot passengers. To get the first one, how do we get a first element of an array? We go to the 0 index. And we want to now assign this to a variable, let first passenger equal that first passenger. Great. Hopefully that makes sense. Continuing on. Passing by reference. Objects are passed by reference. This means when we pass a variable assigned to an object into a function as an argument, the computer interprets the parameter name as pointing to the space in memory holding that object. As a result, functions which change object properties actually mutate, meaning they change the actual same thing that we passed in permanently, even when the object is assigned to a const variable. All right, so if we have let spaceship, this is something that we expect to be able to be mutated. But look at this example, const spaceship. Well, we expect that a constant object is something that you literally can't mutate. You can't change it. And let paint it, you pass in an object, glorious gold. So if I paint it to the spaceship, even though it had a const declaration, it actually will return glorious gold. It actually mutates the property. So be careful with this. This pass by reference is literally passing in the memory that you're setting on in there. It will not obey the const. It will allow you to change it. Let's look at what happened in the code example. We declare the spaceship with the object let. Okay. This allowed us to reassign it to a new object, identified, and transport type properties with no problem. So here is the identified is set to false and transport type. When we tried the same thing using a function designed to reassign the objects passed into it, the reassignment didn't stick, even though calling console.log on the object produced the expected result. When we pass spaceship objects into that function, the object becomes a reference to the memory location of the spaceship object, but not to the spaceship variable. This is because the object parameter of the try reassignment function is a variable of its own right. The body of the try reassignment has no knowledge of the spaceship variable at all. Let's try an example. I think the only way to really understand this is to see a few examples. Write a function, green energy, that has an object as a parameter and sets the object's fuel type property to avocado oil. So we want to create a function, green energy, and it sets the object's fuel type to avocado oil. So if we want to create let, and we want to create what? We want to create this function, green energy. Remember how to create the functions? We need to, one way is say what we want to pass in. In this case, we want to pass in an object. And we're going to then declare this function to say, take the object and do what with it? Well, we want to set the object's fuel type property to avocado oil. Okay, we have an OBJ representing an object. we could take obj fuel type. And what are we going to do with it? They want us to set it always to be avocado oil. Okay. That looks like a function. Write a function remotely disable that has an object as a parameter and sets or reassigns that object's disabled property to true. So to set a new function, let remotely disable. And again, it wants us to take an object as the parameter. So equals an object. And what do we do with it? We're going to use the object and we want to take the disabled property. Now, in this case, we don't have one before, but there's no reason we can't go declare one now. So object disabled and set it to true. Call your two functions with the spaceship object in the code editor, then console log the spaceship objects to confirm those properties were change added. To call that, we can do console.log. Let's do the first one. Let's take green energy as a string equals, and then pass in our spaceship and then call, well, we want to pass the spaceship on in. So we're going to call green energy spaceship. Console.log. And let's take remotely disable equals, and we can call the remotely disable spaceship. Now, in this case, it's not going to return anything. So we would need to first call these. And then how would we access those attributes? We could then perhaps save these. No, that won't work because remember, it's not returning anything. What we'll want to do is just now access those attributes. We can use inside here the spaceship object dot green energy. Will that get us what we want? No. What we need to be doing is accessing what attribute we changed. In green energy, we're changing the fuel type. So just call the fuel type again. All right, let's do the same thing here. Spaceship. What do we need to access to see whether remotely disabled was set correctly? We set up here disabled, so just look at disabled again. All right, let's go ahead and run that. Green energy equals avocado oil. Great. Remotely disabled equals true. True. But did you invoke each of your functions with the spaceship object and then console.log spaceship? Oh, well, I guess it just wants us to just literally use spaceship. No problem. False. There we go. Now it's printing out the whole object, fuel type avocado oil, home planet is Earth, and disabled got appended on in as true. Looping through objects. So just like we did with loops and iterators, you can loop objects too. We learned how to iterate through arrays using their numerical index, but the key value pairs and objects aren't ordered. So JavaScript has given us an alternative solution for iterating through objects with the for ... in syntax. So for ... in will execute a given block of code for each property in an object. So if you have an object that's complex like spaceship, with lots and lots of things. You can do a for ... in for let crew member in spaceship.crew. So let's read how that works. For, and then it's going to look at the spaceship crew, and it's going to let each one that's found in the crew to be called a crew member. For the crew in the spaceship, let each crew member. That's how it's effectively going to do. So it'll then go through this object to say a spaceship has crew, so spaceship.crew. Then we have a captain, a chief officer, a medic, a translator. And what we see it's happening is it's going to loop through each one of those in console.log, the crew member, and then it'll print out their name. Our for ... in iterate will go through each element of the spaceship's crew object. In each iteration, the variable's crew member is set to one of the crew's keys, enabling us to list out everybody's role and name. Let's try it. Using for ... in, iterate through the spaceship.crew object in the code editor and console.log a list of the crew roles and names in the following format. It wants first to have a crew member's role, then the crew member's name. So we should see chief officer is Dan. Chief officer is Dan. Let's try it down here. So for, and then how do we do it? We need to parentheses, let crew member in spaceship.crew. Then we're going to console.log what? We need to do it in the format crew member role and then the crew member's name. So we want to see chief officer : Dan. So to do this, we could take the crew member, oops, I misspelled it. Crew member dot what? How do we get a name and role? First, we would take the crew member to get their role. That is going to just be the key. And then we want to have a colon. And we want to have its name. Well, close. Let's see. Captain, undefined, 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 undefined. What did we do wrong? What we want is something like this, but how do we get the name? If you end up getting stuck, you can view the solution and get some assistance. And I'll give you a help out here. What you'll see is that when we did it, we forgot to include on in the crew member is in the spaceship. So when you get the crew member, that's okay, but you still have to access, though, within the spaceship, that crew member. Otherwise, what you're getting back is just literally the name or the role name, but we're not going to get which crew number. So let's go back. You'll have to take the spaceship again, go into the crew, find the crew member, and get the name object. Now we get Lily, Dan, Clementine, and Shwana as we expect. But apparently I've still done it wrong. What did they want? Console.log in the correct format. I thought I did. Crew member plus name. Medic. Was there a space there that I forgot? Do they want a space? Not sure. What did I do wrong? Oh, the joys of coding. They want a space, so I will put a space after it. Good, now it's happy. Using the for ... in iterator through the spaceship crew object in the code editor and console.log, a list of crew names and degrees in the following format: crew member's name, colon, probably a space, crew member's degree, i.e. Lily, colon, computer engineer. So let's do another loop. For let crew member in spaceship.crew, console.log, crew member, because we have that attribute, plus a colon with a space, plus spaceship.crew, because we need to be able to access the attribute of the crew member. We need to say which crew member it is again, so crew member. And we need to now pull out their degree. But that's wrong. Remember, crew member is just going to pull out their role. So we need to do the same thing over here of spaceship.crew and say what we're actually trying to get on the beginning here is their name. Crew member.name. Now we can see Lily is a computer engineer, Dan is an aerospace engineer, et cetera, et cetera. Next. Okay, that is it for objects. As you can see, you now know everything fundamental for being able to do Web3. We've touched a bit on the previous exercises of how this relates back to doing blockchain, in that we're going to be using the Web3 object, which comes from usually something like MetaMask or another plugin, which is put in the browser, to then access various different properties and methods that allow us to interact with smart contracts that existed on the blockchain. This allows us to store data on something that is fully decentralized. What Web3 is giving us is really a data storage layer, like a database or even a file, but instead of having it in a single place, it gives us a place that is located on many, many, many servers around the world with no central source of ownership. Meaning that once you put it on the blockchain, unless it allows to be changed, literally nobody can change it. And that's a very powerful concept. So in the next couple exercises, which we'll do next year, we're going to take all the knowledge that we've learned around JavaScript, which you needed some foundation to be able to say how software development works. And we're going to apply this object-oriented programming to do some real-world examples using crypto zombies. So we touched on this last time, but if you want, you can go Google for crypto zombies. And it's a great tutorial, but it does assume that you have some basics of understanding how programming works. All of you now, if you've gone through these exercises, will know enough programming to be able to follow the example, and we're going to try out the Solidity course. So I hope this is exciting. Feel free to get started and take a look. I'm not opposed to you guys going ahead and trying out some of these exercises during the winter break, but we will pick up again next year and start going through the beginner to intermediate smart contracts of exactly making the zombie factory, attacking victims, and understanding how Solidity code works for ERC-721s, et cetera. And all this will come together in a Web3 JavaScript front end. So that's it for 2021. Thank you guys for sticking around here, and I'll stop the recording, but pause to see if you guys have any further questions.
Thanks for